A 1 kg wooden block is pressed against a vertical wood wall by a 12 Newton force as shown in figure. If the block is initially at rest, will it move upward, move downward, or stay at rest? Okay. A 1 kg block is pressed against a wooden wall. We have to find out whether it will stay or move up or move down. Okay. So for that, what we will do is we will draw the free body diagram. Here is the free body diagram. And then here are the forces. This is the weight acting vertically downwards. And then here, this is the upward force, whatever it may be. I will write this as F upward force. Okay. And then here the force is applied in this direction. This is the 12 Newton force applied in this direction. And then this is the angle 30 degrees. Okay, so this is equal to 12 cos 30. And then this will be 12 sine 30. Okay, so this is 6 newtons. And then this is equal to 12 cos 30 means 10.39 newtons. Okay, this is Fn. Here Fn acts in the because this is the applied force direction. This is the normal force direction. Now we have to find out the net force. Okay, and then what is the net force? F net is equal to F applied minus F friction. Now what is F friction? F friction is equal to mu Fn. Okay, here mu is 0.5. So F friction is equal to 0.5 times Fn is 10.39. Fn acts in this direction, and then x component of the applied force acts in this direction. So they both will balance each other. Therefore, Fn is equal to 10.39 newtons. Therefore, F friction is equal to 5.2 newtons. Okay, now we will write the upward force. What is the upward force? Okay, so for that, sigma Fy is equal to F upward, okay, plus 6 newtons. This is 6 newtons acting upwards. Applied force, y component of the applied force. Y component of the applied force is 6 newtons minus Fg is equal to 0. Okay, Fg is equal to 9.8, that I will write here. Therefore, F up is upward force is equal to, because the object is in static equilibrium, that is why it is equal to 0. It's equal to Fg is 9.8 minus 6. So F upward is equal to 3.8 newtons. Okay, so the frictional force is greater than the upward force. That is why the objects remain constant, remain at rest, because since 5.2 newtons is greater than 3.8 newtons, or I will write F friction is equal to, is greater than F upward. Therefore, the object stay at rest. Will stay at rest. Okay, so here you should remember that this is applicable for frictional surfaces. Non-frictional surfaces, it will be difficult. Okay, and then you should remember that always the frictional force must be greater than the upward force. Then only it will stay. Here, related to this one more concept is there. Here, somebody is asking another question. You can hold a box against a rough wall and prevent it from slipping down by pressing hard horizontally. How does the application of a horizontal force keep an object from moving vertically? This is a beautiful question, no? See here, again, the same question. Here you are, here it is you are applying the force at an angle, but here you are pressing directly against the wall. So here, what are the forces acting? Applied force, normal force, weight, and then friction. Okay, so the weight is acting downwards, friction is acting upwards, and then the applied force is along the x direction and normal force is in negative x direction, because here, as per the diagram, okay, here what is happening, the more you press against the wall, the object, higher the normal force. Am I right? Because the applied force, I write here, F applied is equal to Fn. Am I right? F applied increase, as F applied increases, Fn increases. Okay. What happens to F friction? As Fn increases, F friction increases. Why? Since F friction is equal to mu Fn. Okay. So that is why the frictional force, as the frictional force increases, the mg will not increase. Fg remains constant because the weight will not change. Therefore, F friction is greater than Fg, so the object remains constant. At rest, it will not move down or it will move up because we are forcing against the wall. So, and the friction here, that is the beauty of the friction. And normal force is also acting not downwards, it is against in the x direction. Okay, understood the concept? See here, the two cases I discussed. One is pushing against the wall directly. Another one is applying the force at an angle. In both the cases, the frictional force must be greater than the weight, Fg. Okay, that is why then only it will stay constant or stay at rest. Okay, frictional force is greater than the total forces, upward forces or downward forces, whatever it may be. Then only it will remain. Here also you see this one, the upward force is greater than the this one. Okay, the upward force is less than the frictional force. That is why it is at rest. The object is at rest. Okay, hope this helps. Thank you. Bye-bye.